Okay, so here's a video on how to work out the molar ratio of two different things in a chemical reaction. So we're going to be using this chemical equation up here. So sodium plus chlorine goes to sodium chloride. So let's say I want to work out the molar ratio, which is going to be really important for some of the next steps. The molar ratio of sodium to chlorine. So what I'm going to do is I'm going to look at what we call these coefficients. I'm going to highlight these in a different color. So the coefficients are the large numbers in front of the different chemicals in a reaction, okay, in a chemical equation. So we're looking here specifically at sodium and chlorine because that's what we're finding out, the molar ratio between Na and Cl2. So when I look at the coefficient in front of Na, sodium, I see a 2. So that's what I'm going to put here. When I look in front of chlorine, I don't see anything. So it's tempting to put a 0, but remember, chemists are lazy. And even though you can't see a coefficient here, there is actually a number 1 there. Okay, it's just we don't usually write it in. So this is going to be 2 to 1. That's the molar ratio, 2 to 1. In the next video, I'll show you how to use that in terms of a conversion factor. But for the moment, that's it. We've worked out the molar ratio between sodium and chlorine. It is 2 to 1. Let's now have a look at the molar ratio between chlorine and NaCl, sodium chloride. So again, I'm going to do the same thing. I'm going to look at the coefficient, okay, in front of chlorine. Again, this is the coefficient here. So that's a 1. And I'm going to look at the coefficient in front of NaCl, and that's a 2. So that's it. The molar ratio between chlorine and sodium chloride is 1 to 2. And then just for completeness' sake, let's do the molar ratio between sodium and NaCl. The exact same thing. I'm going to look at the coefficient in front of sodium. It's 2. And I'm going to look at the coefficient in front of sodium chloride. It's also a 2. So my ratio is 2 to 2. That's it. Okay, as long as you can look at the coefficient in front of the different chemicals in a chemical reaction, you will be able to work out the molar ratio between anything.